You have driven past it 100 times without thinking twice. A rusting steel tank sitting on stilts at the edge of your city. It looks like it has not been updated in decades. There are no visible controls, no obvious power source, and absolutely no moving parts. And right now, that tank is silently controlling the water pressure in thousands of homes, hospitals, and fire hydrants across your entire city without a single pump running. That should not work. Something that looks like a relic from the 1960s should not be outperforming modern technology every single morning. But it does. And by the end of this, you will understand exactly how that primitive-looking tank on legs is quietly doing what millions of dollars in smart equipment still struggles to match, and why tearing it down would be one of the most catastrophic mistakes a city could ever make. To understand why that tower exists, you need to understand the real enemy of every city water system. It is not drought. It is not pipe corrosion. It is time. Specifically, the fact that people use water in completely unpredictable, violent bursts throughout the day. Think about your morning. You wake up, turn on the shower, brush your teeth, maybe run the dishwasher before heading out. Your neighbor does the exact same thing at the exact same time. So does the family across the street. So does the apartment building on the corner. Now multiply that across an entire city. Millions of people doing the same thing at the same moment every single morning. In the space of about 2 hours, a city's water demand does not just rise, it spikes violently. We are talking about demand jumping to 3 or 4 times the overnight baseline in a matter of minutes. Every toilet flushed, every faucet turned, every industrial kitchen firing up at once. Now here is the problem. The pumps that feed your city's water system are not built for this. They are sized for average demand, not peak demand, and there is a very good reason for that. If you sized a pump to handle peak morning demand, you would be running a massively oversized, energy-hungry machine at 10% capacity for most of the day. That is economically insane. No city can justify that cost. Think of it this way. Trying to run a city's water supply purely on pumps is like trying to power a football stadium through a single extension cord. The moment demand spikes past what that cord can carry, the whole system fails. Pressure drops. The cord burns out. Pumps have the exact same limitation. They can only push so much water so fast, and when an entire city wakes up at once, they simply cannot keep up. And even if you could somehow justify the expense of an enormous pump, there is another problem. A pump that large takes time to spin up to full power. It cannot go from idle to maximum output instantly, but water demand does not wait. It hits all at once, without warning, every single morning. So engineers looked at this problem and did something clever. They did not try to build a bigger pump. They did not try to make the system faster. Instead, they found a way to store energy. Here is what actually happens. Overnight, when almost nobody is using water, a relatively small and efficient pump switches on. It does not need to be powerful. It does not need to be fast. It just needs to be steady. For hours, while the city sleeps, that pump pushes water upward into the tower, filling it slowly to capacity. A typical water tower holds anywhere from 500,000 to 1 million gallons. That is an enormous amount of water sitting quietly in the dark, waiting. But the water itself is not the point. Something invisible is happening as it climbs. Every gallon the pump pushes upward is a conversion. The pump is taking electrical energy and turning it into gravitational potential energy. It is, in effect, winding a spring, loading a catapult, charging a battery made entirely out of water and height. The higher the water goes, the more energy is stored. And all of that energy sits there, perfectly preserved, costing nothing, losing nothing, until the moment it is needed. Then morning hits. 6 o'clock. Demand spikes across the city like a switch being flipped, and the tower responds instantly. Water begins flowing out of the tank and into the distribution network below, feeding pressure to every pipe, every faucet, every hydrant connected to the system. No emergency pump fires up. No backup system kicks in. The tower simply releases the energy that was stored hours earlier, and gravity does the rest. Think of it like a fully loaded syringe held above your head. Nobody is pushing the plunger. There is no motor involved. Gravity is doing the pushing. The higher you hold that syringe, the harder the water comes out. That is the entire principle behind a water tower. Elevation is pressure, and everything else in the system flows from that one idea. Here is what makes this so remarkable. The pump that filled the tower ran overnight, when electricity rates were at their absolute lowest. It ran during the hours when demand on the grid was minimal, and now, during the most expensive, most demanding hours of the day, the city is getting its water pressure for free. The energy was already spent. The bill was already paid. The tower is simply returning what was given to it, silently and without complaint. The plunger was loaded last night. This morning, gravity is doing all the work. And gravity never overheats. It never breaks down. It never needs a technician. And it never sends your city an electricity bill. The pump did its job in the quiet hours. Now the tower is doing its job in the loud ones. Here is where most people's understanding breaks down completely. When you turn on your tap, you probably imagine a pump somewhere deep in the system roaring to life and pushing water directly toward your house. That is not what is happening. In a system with a water tower, the pressure at your tap was set before you even woke up. It was set the moment the tower was filled. The pump did its job hours ago. What you are feeling when that water hits your hand is not mechanical force. It is weight. Pressure in a water tower system is not created by pumps at the moment of use. It is created by the sheer weight of water sitting above you. This is called hydrostatic pressure, and it is one of the oldest and most reliable forces in engineering. The physics are beautifully simple. Every single foot of water elevation generates approximately 0.43 pounds per square inch of pressure at the base. That means a water tower with water sitting 150 feet above your tap is delivering around 65 pounds per square inch of pressure, consistently, silently, without any variation at all. If you want to feel what this force actually is, think about the last time you dove to the bottom of a swimming pool. Remember that uncomfortable squeezing sensation in your ears as you went deeper. That pressure pushing against you from every direction. That is the weight of the water above you pressing down. The deeper you go, the harder it pushes. A water tower works on the exact same principle. The higher the water sits above your tap, the harder it flows when you open it. And here is the critical part that makes the entire system work. That pressure is constant. It does not fluctuate based on how many of your neighbors are showering at the same time. It does not drop when a pump stutters somewhere across the city. It does not surge unpredictably when demand suddenly falls. As long as there is water in that tank above you, the pressure in your pipes remains stable within a remarkably narrow range. It just sits there, steady, doing exactly what it is supposed to do. For most people at home, that consistency is a convenience. You expect the shower to feel the same every morning, and it does. But for hospitals running dialysis machines that depend on precise water pressure, for fire suppression systems that need instant full pressure flow the second they activate, for industrial facilities operating sensitive hydraulic equipment, that consistency is not a convenience. It is a non-negotiable requirement. Lives depend on it. And a passive tank filled with water and gravity delivers it more reliably than any pump ever built. So if the system is this simple and this effective, a fair question follows. Why haven't we replaced it? We have sensors now. We have smart grid technology. We have pumps that can modulate pressure in milliseconds and variable speed drives that adjust output on the fly. Surely all of that makes a passive steel tank on legs obsolete. It is a reasonable assumption, and it is wrong. Here is what modern alternatives cannot do. They cannot do all three of the things a water tower does at the same time, at the same cost, with the same simplicity. And those three things are what make a water tower irreplaceable. The first is emergency volume. A water tower holding 750,000 gallons is not just a pressure tool. It is an emergency reservoir. When a main pipe bursts somewhere in the network, when a pumping station loses power unexpectedly, when a wildfire erupts and every hydrant in an entire neighborhood needs to deliver massive flow simultaneously, that tower is the buffer standing between your city and catastrophe. It does not need to be activated. It does not need someone to flip a switch. It is already full, already pressurized, already delivering. It can sustain a community for hours while the crisis is being resolved. No modern pump station can sit passively ready like that without consuming energy every second it waits. The second is pressure during power outages. Pump stations run on electricity. That is an unavoidable fact. When the grid goes down, they stop. Backup generators can help, but they take time to start, they require fuel, and they introduce complexity into a moment that demands simplicity. Gravity does not care about the electrical grid. A full water tower continues delivering pressure for hours into a blackout. Hospitals keep running. Fire suppression systems stay live. Water keeps flowing to the people who need it most. There is no switchover delay, no startup sequence, no fuel dependency. The water simply falls, the same way it always does. The third is cost. Every additional gallon a pump delivers during peak hours costs money. The electricity to run it, the wear on the equipment, the maintenance to keep it operating under heavy load. Every gallon flowing from a water tower during peak hours costs nothing extra. The energy was already spent overnight, when electricity rates were at their lowest. You charge the system when power is cheap. You discharge it when demand is high. And the infrastructure that makes this possible costs almost nothing to operate once it is built. The economics are almost unfair. Modern alternatives have their place. High-pressure pump stations serve dense urban cores where building a tower is impractical. Variable speed drives improve efficiency in systems that already exist. Pressurized ground-level tanks work in specific situations, but none of those solutions are gravity. None of them operate with zero energy input during the exact hours when energy matters most, and none of them combine emergency storage, outage resilience, and peak demand economics into a single structure that has no moving parts. There is a reason cities with populations in the hundreds of thousands still rely on water towers that are 50 or 60 years old and still in daily service. It is not because those cities cannot afford something newer. It is because nothing newer does everything that tower does. So the next time you drive past that rusting tank on stilts at the edge of your city, you will know what it actually is. It is not aging infrastructure waiting to be torn down. It is not a relic of outdated engineering. It is a passive gravity battery that your city depends on more than almost any other single structure. It stores energy when no one needs it and releases it the moment everyone does. It keeps pressure steady when pumps fail, keeps water flowing when the power grid goes dark, and does all of it without a single moving part. The most reliable system in your city has no software, no electronics, and no maintenance schedule that comes anywhere close to what modern alternatives demand. It runs on a force that has existed since the beginning of the universe. And that is the part worth remembering. Sometimes the most sophisticated solution to an engineering problem does not look sophisticated at all. Sometimes It looks like a steel tank on legs that has been sitting quietly at the edge of town for 60 years, doing exactly what it was built to do. Nothing. And that is exactly the point. If you enjoyed this video, make sure to like and subscribe, and see you in the next one.